speaker is Sören Holm. He is professor at the Center for Social Ethics and Policy at the University of Manchester and also at the Center for Medical Ethics at the University of Oslo. He holds degrees in medicine, philosophy and religious studies from the University of Copenhagen, as well as a master's degree in healthcare ethics from the Danish Hospital Institute. Thank you very much for joining us.
Thank you. Thank you for the invite and for having an opportunity to visit one of the several world cities that Switzerland is so lucky to have. I need to acknowledge that my thinking about this is paid for by the Horizon 2020 program of the European Union as part of the Responsible Open Science in Europe, or ROSI project. Now, open science, I think, is acknowledged by everyone to be a good thing. It's very difficult to say that open science is not a good thing. But it's important for what I want to say today that there are several different justifications for what we hope to achieve by open science, and that open science itself is a work in progress. Now, traditionally, open science efforts has been focused on open access, which I think, at least as far as it goes to published results, is likely to be achieved within the next 5 to 10 years, at least for those of us who have reliable web access. And for some of my later arguments, it's quite important to note that there are many people in the world who do not have reliable web access. Even many researchers in the world at universities who don't have that. Then we have the whole concept of open data, including the FAIR principles for exactly how we should make data open, and how we'll include in that open code, open analytics, and then in relation to clinical trials, we have the idea that these should be pre-registered, which Julian have already mentioned. So my focus here will be on two issues around open data. Now, just to illustrate that there are many different justifications. This is a classic in the field, Fächer and Friesige, open science, one term, 5 schools of thought, where they identified 5 different possible ways of justifying open science, and as you can see, it has an open source license which allows me, since what I'm doing now, I take it is not commercial, to reproduce it in this particular presentation. Now, seen from a more philosophical point of view, I've listed some of the justifications for open data here. One thing that has already been pointed out in the previous presentations is that we can justify that data should be made openly available by efficiency of scientific production, by reuse of data. And insofar as these data have been generated using public resources, it's also a way of optimizing those resources. Then within psychology research, open data has been justified very significantly in relation to the ability to reproduce the results of other people, which is a huge problem in experimental psychology. There are equity or equality justifications. It's often claimed that if we have open data, it will engender public trust in science, although there is a very interesting argument by Stephen Johns that this is not certain. There's no good empirical evidence for the proposition, and there are good theoretical reasons to be somewhat skeptical that this will always happen. And then we might say that openness and transparency is simply a good in itself, that being open and transparent is good. Now, I take it that all of these justifications are at least partly true. But what I want to argue in the next part of the presentation is that if they're true, they're not only true for data, that they're true for many other things that scientists produce, and that there's no good reason for limiting open science to open data, the sharing of codes, data, analytic methods. Almost all of the justification for open data extend beyond data to other things, like access to research sites, bespoke reagents and lab results, genetically modified model organisms, so fruit flies, mice, whatever, and all of the other things that scientists produce and which are necessary in their work to produce their results. Now, all of these things are shared today, but they're often shared either in being traded for co-authorship, or they are not shared and kept as the researcher's proprietary property and strictly guarded. A recent paper has called this idea that access to research sites and other things are the property of researchers as the Gollum effect. Those of you who know The Lord of the Rings will know that Gollum was very, very possessive of the ring. And there are researchers who are very, very possessive of their genetically modified model organisms or their research sites. But it's important to remember that this is exactly how researchers used to treat the data sets they had generated and curated. It is not so long ago that data were not shared, and they were not shared precisely because researchers thought that they had personal incentives in not sharing them. Now, there is a very common counter-argument to the extension of open science, and that is that the things that we should be shared, the reagents and so on, are or embody intellectual property, and therefore they should not be shared freely. They're worth something. Now, this is true in some circumstances, but it is false in most unless we equivocate, i.e., use the fact that intellectual property means a number of different things. Something is my intellectual property because I thought of it first. So I could have intellectual property in that sense in a philosophical idea. Now, those of you who know patent law will know that I cannot patent philosophical ideas, even if they're great and wonderful. So there's also a much stricter legal meaning of intellectual property. And many of the things that people, researchers, say they have intellectual property in, they have in the colloquial sense. They have some idea that these things are theirs because they thought of them first. But they could never have intellectual property in the legal sense. And we also need that the specific design of databases can also constitute legally protectable IP, but we don't accept that as a reason not to make data open. Now, there are a number of other analogy arguments that we could make, showing that sort of the fact that something involves work, effort, thought, that making something shareable involves work, effort, and thought, that sharing them does not allow the originator sufficient reward. We have decided in relation to open data that these things are not relevant. People ought to work up their data sets to fair standards, even if that involves work, effort, thought, and so on. So why shouldn't we apply the same beyond data? So that's my first question. My second beyond question is around open science beyond borders, and especially about a problem with thinking about open data. Now, open data is in principle symmetrical. Every researcher provides open data. Every researcher can use open data provided by others in their research. Now, the generation of open data to fair standards and the productive use of available open data both require quite significant resources. Providing the kind of metadata that allows other people fully to understand your data set requires quite a lot of work. And if you want to use other people's data, that also requires quite a lot of work. But it is a fact that resources are very unevenly distributed between research groups, and that researchers in the scientific periphery tend to have far fewer resources and far less stable resources than researchers that are closer to the scientific core. Now, this has some consequences. Given that generating open data to fair standards requires work, if you have fewer resources, then you will have to use proportionally more of your already limited resources to do that. So those who have limited resources will be able to do less research within their resource envelope if they are to fulfill open data mandates. And they will also be less likely to be able to exploit available open data, because that also takes resources. And for instance, it might mean that you need a stable electricity supply, which many researchers in the scientific periphery does not have. Now, this means that a commitment to open data is likely, perhaps even certain, to create an instance of the Matthew effect, first identified by Merton in the 1960s, unless something is done. And for those of you who is not strong on the Bible, the Matthew effect refers to Matthew 13:12, for whosoever hath, to him shall be given, and he shall have more abundance. But whosoever hath not, from him shall be taken away even that he hath. So the Matthew effect is simply that those who already have resources are able to use them productively. Those who have less resources will eventually lose out in the competition, and science is a competition. Now, this second problem about open science beyond borders, what solutions could we suggest for that? Now, there are a number of ways that the justice problem involved in requiring researchers in the scientific periphery to provide open data could be resolved. We could provide additional financial resources to them to enable data to be curated to fair standards. We could implement systems that ensure that the originators of a particular open data set receive adequate academic and potentially financial credit when the data set is reused. Now, the second of these solutions requires us to solve a quite difficult problem. And that is, and this is not limited to the issue beyond borders, but it's also a more general issue for our academic processes, for employment, promotion, many other processes. But what is the adequate credit when an open data set is reused? If I have spent a lot of time collecting the data, I have produced the metadata to fair standards so that these data are easily usable by other researchers. Well, what is adequate credit for my intellectual and other efforts? Now, obviously, the minimum is that those who use my data are explicit in their acknowledgement, that they acknowledge clearly in their publications and other places that they have used my data sets. Now, this doesn't give me much unless our systems for evaluating academic merit are aligned with that. So we find a way of actually giving people merit for the fact that other people have found their data set to be valuable and have used it in their research. So our policies for CVs, for employment, promotion, other things need to take this into account. And when these data sets are data sets that are derived by people in the scientific periphery, we need to take account of the differential opportunity costs in doing this between different researchers and research groups. And maybe, even though we could use these data sets without collaborating with the people who have generated them, maybe those of us who are close to the scientific core and have the resources should instead decide, well, we could use these data without collaboration, but we will collaborate, because this is the only realistic way in which we can give those who actually did the work, produced the data sets, adequate credit in these specific situations. Thank you.